So there are three different pain mechanisms. There is the gate control theory, there is the descending pain modulation or the central biasing, and then there is the endorphin release. So starting with pain control theory, so that's like the main one. Basically what occurs with the pain control or gate control theory is that you start with a noxious stimuli. So a noxious stimuli is a pain stimulus. It is in the form of A delta fibers or C fibers. So you start, like, let's say you got pinched. Well, right now I got pinched, so those pain receptors, those nociceptors, are getting sent to the dorsal horn in my spinal cord. And the dorsal horn acts as the gate that controls what stimulus comes into the gate and goes up into through the spinal cord up to the central nervous system or the midbrain where pain is perceived. So what the gate control theory is saying is that, let's say I got pinched. Well, after I get pinched, I'm going to rub it. And when I rub it, the pain's gone. So it took away the pain. So what is occurring there and why that is a thing is the fact that you have three different stimulus. You have motor stimuli, you have sensory stimuli, and you have pain stimuli. So some of them are faster than others. For example, in this situation, sensory stimuli is in the form of A beta fibers, and sensory stimuli is faster than pain stimuli. So those A beta fibers are faster than the C fibers or the 8 delta. So when you get pinched and then you rub it, basically those nociceptors are getting sent, that stimulus is getting sent to the dorsal horn. Well, so is, after you start rubbing it, so is now that sensory stimuli. The sensory stimuli is faster than the pain stimuli. So the sensory stimuli gets to that gate, which is the dorsal horn, before the pain stimuli does. That's why it stops your pain, because it blocks, they both can't go through at the same time. And you have two different nerves in your body, so pain is traveled through these small nerves, and then you have your sensory and your motor, which is travels through your bigger nerves. So both of them cannot go through this gate at the same time. So your body, since the sensory stimuli is faster than your pain stimuli, your body blocks off that pain stimuli so that the sensory stimuli can be traveled up all the way up to your midbrain. And that is why when you get pinched or anything like that, any sensory stimuli after pain causes the pain to stop. So if I stub my toe and I rub it, or I shake it around, or if I burn myself and then I feel pain and I take it off and I shake my hand, the pain is going to subside. Then you have central biasing, which is also the descending pain mechanism. So in gate control, that is an afferent mechanism. So basically that means that it's an afferent transmission. Pain is going from the outside of your body to the spinal cord all the way up to the midbrain, and that's when it's stopping. Well, in central biasing, it is starting in the midbrain where pain is perceived, and it is traveling down. So it's different. It's traveling from the central nervous system all the way down to the rest of the body. So basically in central biasing, pain is inhibiting pain. An example of this is acupuncture. So you're getting a painful stimuli and it's stopping a greater pain. So basically the nociceptors and the C fibers stimulate the midbrain by the PAG, which is the periaqueductal gray. The periaqueductal gray is within the midbrain, which is where pain is perceived. What the PAG does is it sends neurons to the RAF nucleus, which is in the medulla of your brain. So this is where serotonin is released. So once the PAG stimulates those RAF nuclei, serotonin is released, which is an endogenous opiate. Serotonin is a natural pain reliever, but what the serotonin does is it sends stimulus through, or it travels through the spinal cord to the site of where the pain is located, and that is where the enkephalin is released at the dorsal horn. The dorsal horn then lets the enkephalin out, and it causes the pain to be stopped at that site. So in this one, the difference is from the gate control is that instead of going from the stimuli up to the midbrain, it's going from the midbrain all the way down to where the stimuli occurred. So it's just a different transmission. And it's also pain inhibiting pain instead of, in the gate control theory, it's stimuli stopping a pain. Then you have your endorphin release, which is like motor pain control. What happens in endorphin release is the A delta fibers they stimulate the pituitary gland. So this one involves the pituitary gland to release endorphins or endogenous opiates for prolonged pain relief. So an example of this is like low intensity E-stim with a longer duration. So you would go for longer, but it's a lower intensity. Also, what happens here is, so basically, since the pituitary is involved, ACTH, adrenocorticotropic, is being released as well as these other endorphins. The messages are sent through the spinal thalamic tract all the way down to the stimuli. So that is kind of the difference. Is one is gate control is based on sensory. Central biasing is based on pain, so nociceptors, and then the endorphin release is kind of based more on motor. So they're all three different pathways of how pain is traveled and how pain is stopped in the body, but they're all three using three different fibers. So obviously sensory is A beta, you have A alpha for motor, and then you have for pain or nociceptors, you have C fibers and A delta. And they all take a different pathway through the body, but they all start and end at the midbrain. So either they start at the midbrain and they travel down to the dorsal horn, which is where pain is, like stimulus are sent up through the body, because that's like the entrance, right? You have your spinal cord, and the dorsal horn is where all that stimuli is like brought in. And then, but you have your dorsal horn can either be the start or the finish, as well as the midbrain. So, and then you have in between, you have the spinal cord and the rest of the brain, like such as the medulla, which it plays a part in the Raphe nucleus and central biasing. But those are the three different pain control theories.